Hi everyone, so we already covered 3.2 NaN equation in the last video. So next we will cover 3.3 electrolytic cell. At the end of this lesson, students should be able to first draw an electrolytic cell, second describe the operation of an electrolytic cell, and third, explain the influence factors on the selective discharge of a species at the electrode, which is SRP of the species, concentration of the species, and the nature of the electrode. Okay, so this is diagram of electrolytic cell. Okay, so we have one beaker, only one beaker, one electrolyte, okay, and two electrodes immersed in one electrolyte. And electrolytic cells consist of electric source such as battery. Okay, right? So remember, don't panic. Positive is anode, negative is cathode. That is different between electrolytic cell and galvanic cells, but still red cathode undergo reduction, okay, anode undergo oxidation. Okay, so next is I will explain about anode and cathode. So anode is a positive electrode, the electrode which is connected to the positive terminal of the battery, and oxidation takes place. While cathode is a negative electrode, the electrode which is connected to the negative terminal of the battery, and reduction takes place. And electrons flow from anode to cathode. Okay, operation of an electrolytic cell. Electrolytic cell consists of a vessel containing electrolytes. So this is electrolytes, either as aqueous solution or in molten state. Okay, so two electrodes are dipped into it. Okay, two electrodes, anode and cathode, okay, connected to two terminals of electricity source such as battery. So this is electricity source. Okay, the electrode that is connected to negative pole, okay, the shorter one, the shorter of the battery symbol, this is negative pole. Okay, connected to negative pole, this is cathode. Okay, and it's a negative terminal, which another electrode which is connected to the positive pole, okay, is called anode. Okay, and this is positive terminal. Okay, let's look at this example of an electrolytic cells when we use molten electrolyte as its electrolyte. Okay, so during electrolysis, a molten electrolysis is decomposed into positive and negative ions. Okay, alright, so positive ions, or we can call as cation, okay, are attracted to cathode, negative electrode. Okay, and the positive ion will accept, so this is cation, okay, will accept the electron from cathode and become a neutral in charge. Okay, first the cation is a positive charge, accept electron and become neutral. Okay, what will happen to the anion? While negative ion or anion, okay, migrate towards the anode, okay, this is anode, right? Lose electron, okay, from negative charge, okay, lose electron, okay, so electron will be at the product, okay, and become neutral. Okay, so anion go to anode, cation go to cathode. Alright, so this is an example for electrolysis of molten NaCl. So this is the electrolyte, the molten NaCl. So when I say molten NaCl, means the NaCl, which is in the form of in a room temperature, is actually solid, but when we put in the hot vessel in a high temperature, it becomes liquid. Okay, so in molten sodium chloride, only Na plus ion and Cl minus ion are present, so no water. Okay, it's not aqueous, this is molten, only Na and Cl ion. Okay, so what will happen? Na plus will attracted to cathode, which is this is cation. Cation will attracted to cathode, while anion Cl minus will attracted to anode. Okay, so cathode, the reduction will take place. Okay, so what will happen to the Na plus? Will accept the electron and become sodium liquid. Okay, sodium liquid because it's still in the hot vessel. Okay, meanwhile, in the anode side, okay, so oxidation will take place. So chlorine ion, okay, chlorine ion will release electron, okay, and will transform into chlorine gas. Okay, so oxidation will happen at anode, reduction will happen at cathode. Right, so next we cover electrolysis of aqueous solution. So aqueous solutions form when a salt dissolves in water. So salt is an ionic compound which dissociate completely in water to form positive ion and negative ion. But in aqueous solution, not only we have positive ion and negative ion that come from the salt, but also the water molecule. So in chapter 7, we have learned that water molecules does not dissociate completely to form H plus and OH minus. So H2O has a partially positive and partially negative end, right? So cathode, okay, a negative electrode will attract positive ion and partially positive end of H2O, okay. H2O, let's draw H2O molecules. This is O and we have 2 H, like Mickey Mouse shape. Okay, so this is positive, positive end, partially positive end, and but O carries the partially negative end. Okay, right, while anode, okay, the positive electrode will attract negative ion and partially negative end of H2O molecules. Okay, so the species that will selected to discharge on each electrode depends on 3 factors that will be discussed later. Right, example 2, electrolysis of sodium sulfate aqueous solution. Okay, so we have sodium sulfate aqueous solution as an electrolyte. Okay, but sodium sulfate aqueous solution contain not only sodium ion and sulfate ion but also water molecules. Okay, right, so cathode attracts sodium ion and water molecules. So which one will be selected to discharge will be discussed later. Okay, while in anode, okay, anion and water molecules. So anode attracts sulfate ion and water molecules. Which one will be selected to be discharged will be discussed on next video. Thank you.